Hi guys, welcome back to Pinet Labs. My name is Chirag and in this session today we are going to explore model driven programmability. So let's get started and let's understand how model driven programmability works and how it is different from the normal automation which we have been discussing and practicing in the previous sessions. So let's get started without wasting any time. The topic for today is model driven programmability, which I would say is a quite crucial part of this particular training. When we talk about model driven programmability, we get to see two major protocols there, the NETCONF and RESTCONF. In this session today, we are going to focus on the protocol NETCONF and we'll try to understand how the NETCONF works and how it operates. But before jumping on to NETCONF, the question is that what is this model driven programmability? When we talk about normal automation, which is basically using the libraries like NetMiko, which we have discussed earlier, we get to see a configuration, a set of CLI commands. We send these CLI commands from my script to the router and we basically perform the configurations. That's how we have achieved the tasks, right? But in this exchange of commands, which I am writing in my NetMiko script with the router, my PC is not understanding anything, right? My PC is just simply working as a mediator who takes the command from me from the script and then push them onto the CLI of the router to make configuration. My PC doesn't understand anything related to the CLI commands. But when I talk about model driven programmability like NetConf, under NetConf, we use some data structuring languages which are even understood by my PC. So now, when I use model driven programmability, I get the ability of performing some tasks on the basis of information I am fetching out of the device. Because now my PC understands that whatever I have fetched, my PC can read that data. And once it can read that data, it can take the actions more effectively, right? It can take the continuous actions or it can take the next steps to make the configurations completed by just reading the data itself. It doesn't require the human intervention there. So when we talk about the first protocol of model driven programmability, which allows us with all these features where my PC can even read the data. So we have got the netconf there. Now under netconf, we get to see different operations. So there are three major operations under netconf, which we use with networking. That is get config, and edit config. When we talk about the operation get is used to fetch operational data from device. When I talk about get config is used to fetch configurational data from device. When we talk about edit config is used for modifying or creating configurations on the device. These are the three operations which we get to see. Now the clarity is there that get and get config is used to fetch out the information from my router and edit config is used to push the new configuration or modify the existing configuration of the device. But there is this thing, operational data and configurational data. So let's try to understand the difference between the operational and configurational data. Let's say you go on a device and you run the command show interface fa0/0. When you execute this command on your CLI, you get some certain types of outputs. It will generate some information in front of you, which will basically include things like the IP address, or we can say the state of my interface. It will tell me about the duplex, the speed of my interface, the MTU configured, and then so on, right? Such configurations or such data will be there. And along with that type of information, there will be another type of information which is going to be related to the statistics, like how many unicast packets were sent or received, how many multicast packets were sent or received on the interface, then how many broadcast packets were sent or received on the interface, how many packets were dropped, and then again so on. So all these things which provides the statistics of a particular information onto my router, that is your operational data. So this type of data we call as operational data. And all the things which you can configure on the device, like the IP address of the interface, like the state of the interface, like the duplex, the speed, MTU, all these things, these are called configurational data. So when you wish to fetch the configurational data, the operation you need to use is get config. And when you want to fetch the operational data, the operation which you are going to use is going to be simply get. That's the difference between my operational and configurational data. After understanding this, the next thing which we need to know about is basically the components of NETCONF. So let's understand how this NETCONF protocol stack works. The very first thing to know about NETCONF is that it uses, or we can say it does, transportation using SSH but on port 830. So the transport it uses is going to be SSH. It will create a SSH connection with your target device, but the connectivity will be built over the port number 830, which is basically the default port which is utilized by the NetConf. If it is on something else, if it is on some other port number, then it will not work. So it has to be on 830 only to make it work. After that, the second point is about the data structuring languages. So it requires data structuring language, which in this case is going to be XML, extensible markup language. Now, this XML is something, as I mentioned earlier, also, it is something which my PC will understand. So I can tell my PC to take actions on the basis of output. So I can tell my PC to take the uh, certain actions on the basis of the information which I'm fetching from the router. But there are only some specific operating systems which can understand the XML. So for that reason, NetConf can't be utilized with all of the routers or all of the network devices. When we talk about NetConf or RESTConf, This can be utilized with only operating systems that are iOS XE in the case of Cisco. So these are the three operating system: iOS XE, iOS XR, and NXOS. So that means the iOS router which we have been configuring using NetMiko is not something which we can configure using NetConf. So for using NetConf, you need a device from one of the operating system mentioned here. Now, the data structuring language, which is XML, is going to be understood by my target device. Then only I can make the configurations, right? The third thing about NetConf is that we have a data modeling language as well, which is Yang. So Yang is going to be a data modeling language. Now let's talk about these pointers one by one again. So the very first pointer is about transportation. The transport it is going to use is SSH. It will create a connection on port number 830 with the help of the SSH protocol. Second point, it requires data structuring language. So the DSL is there to provide a structure to your data. So there is going to be a payload which we will write. This payload is going to be in the terminology of XML, which we will send on to the router, the iOS XE router or iOS XR router. So this data which we write here, the payload, is supposed to be defined in the terms of XML. So data structuring languages are there to provide a structure to the data. In normal automation, the input and output which we give is in the form of iOS CLI, which is understood by me, understood by the network device, but not by the PC. But when it comes to NetConf utilizes XML to communicate with the device. This means that we will no longer will be writing the CLI commands in the script. We'll have to understand the XML to make configurations using the NetConf. So there won't be CLI commands for fetching the configurations or pushing the configurations. It will be done in the form of XML. Now let's take an example here. Let's understand how the XML data would look like. So for example, let's say there is some interface related parameters. There is the name of the interface, that is gig 0/0. Then we have the description of the interface, which says connected to MPLS. Then we have the IP of my interface, which is, let's say, 192.1.1.1. Then we have the mask of my interface, that is 255.255.255.0. And then there is the state of my interface, which is up. Now, for example, if I try to write this whole data in the terminology of XML, so the data would look something like this. There is going to be a tag called interface, inside which we'll have another tag called name, inside which I'll have the value gig 0/0. And then I will close the name tag like this. Now, this is something similar to HTML. So if you might have before worked with the HTML language, then you must be aware how this thing works, right? Then along with the name tag, there is going to be the other information as well, like the description. Now, these are not the exact values, but yeah, definitely this is an example here to understand how the data would look like. So it will read connected to MPLS, then I'll close the description tag. Then I'll have a tag called IP, in which I'll put the value 192.1.1.1. Then I'll close the IP tag. After that, I'll have a tag called mask, where I'll have the value 255.255.255.0, and then I'll close the mask tag. Similarly, I'll have a tag called state in which the value is going to be up, and then I'll close the state tag. Lastly, I'll close the interface tag, which basically completes the interface related information. Like this. This is how the data will look like in the form of XML. So that's basically the use of tags, which we need to understand, and the closing of tags, which we need to understand in order to understand XML. Now the information will be completely understood by the PC also. So as mentioned by me earlier also, if you want to create a task like, for example, if the name of interface is gig00, then configure IP 192.168.1.1, then you can totally depend upon your PC. Your PC will be able to read the name, and if it matches with the condition which you have defined, it will configure the provided IP on the interface. But that is not quite easy to achieve using libraries like NetMiko. I won't say that it is not possible with NetMiko. It is definitely possible, but that would require a huge code. That would require you to define all the conditions manually. But when it comes to NetConf allows my user or allows my PC to read the data, which makes it easy for taking actions on the basis of the output. That's how the data structuring language works. Now, another thing which we have discussed is the data modeling language, which is Yang, right? So let's understand what are the data models and how they help us in ensuring that the configurations we are pushing on the device are correct. So we will try to understand the data validation process by a quick example. So let's say that there is a web form which you have opened up. Now this web form basically asks you questions about your name, then your location, then the organization you work in, then your role in the organization and your domain. So these are few things which my web form is basically going to inquire about from me. The name, location, organization, role, and domain. Now, after filling the information, there is going to be one submit button, which you will click. And after that, this information will be stored into some data store. So there is going to be a server where your information will be stored. There will be a field of name, there will be a field of location, then organization, then role, and then so on. Now let's say I open this form, I'll fill the information. I'll say Chirag is the name, location is Delhi, organization is Pinet Labs, then role is instructor, and domain is Cisco. The moment I click submit, the information will be added into my database where one entry will be created with the name Chirag, location Delhi, organization Pinet Labs, role instructor, right? That's how it will work. But let's say now some other user opens up the form and they fill in something incorrect. They give the name as 1234. They give the location as special characters like this. They give the organization name as exclamatory marks. They give the role as hyphens and the domain again as some alphabets A, B, C, D. Now, this time when my user will try to click on the submit button, most probably it will get the error invalid input detected, right? Why do we get this error? We get this error because my developer, the person who has created this web form, has already defined some rules. Some rules like that the name should be a string. It can't be integers. The name should be minimum of 3 characters or a maximum of 10 characters, then similarly, um, we can say location can't have any special characters. Then it should be a string. It should be of maximum 20 characters, and then so on, depending upon what type of information you are taking. With the help of these rules, I can I can ignore, or we can say we can avoid the invalid or wrong data, which would probably enter into my database if there were no such rules, right? If there were no such rules, the entry will be created like this: at the rate, at the rate, at the rate, exclamatory, 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 1, 2, 3, 4, and then so on. And this wrong entry I would have to remove later on. So when I talk about these rules, they help me in avoiding the post processing efforts. So it will save a lot of time for me. It will save a lot of efforts. I will not have to do post processing, and it will basically first validate the information according to the rules. If it is found to be correct, then only it will add it into the data store. In the same manner, data models work. Now, when you write your script, you will refer to a data model. Data model is something like the rules, and this data model is written in language Yang. So you will be referring to this data model while writing your script. And when you will send it on to the router will first validate this with the data model. If it finds that the script which you have written is in the accordance to the data model, then only it will get that script executed. Or we can say then only it will make the changes into the configuration. Otherwise, it will send me back some error if it doesn't get validated in the case of no validation. So these data models are already going to be present in the iOS file, or we can say in the operating system of your router. Whatever router you select, it will already have all these data models, and they are available for each and every type of configuration, be it interface configuration, be it EIGRP configuration, be it OSPF configuration, or whatnot. Whenever you try to make any configuration, you will refer to some data model. If the script is created as per the data model, it will get executed. Otherwise, it will send back this error, which will say that there is some issues in the script. Please modify this and make the changes. Now, who creates this data model? Who is creating this, or who is defining all these rules? So Yang data models are created by two entities, we can say. We can say data models are created by two entities. The first one out of which is standard bodies. Standard bodies like IETF and OpenConfig. And then along with standard bodies, the vendors also create these data models. Vendors like Cisco, Juniper, F5, and then so on. All these vendors are there providing the data models for different types of configurations. This is how the whole thing works, and the reason why we call it as model driven programmability is that first my data or my Python script will which will contain the XML body will get validated according to the data model. And then if the data model is uh, basically if the script is as per the data model, then only it will get executed. Otherwise, it will deny the configuration and will send me back with some error. So that's the reason why we call it as model driven programmability. I hope this explains how the NetConf works. And in the next session, we are going to observe some lab where we will try to use NetConf to interact with the iOS XE device. And we'll see how things work and how it operates when it comes to dealing with the network devices. So thank you so much, everyone. I hope you enjoyed the session and got to learn out of it. And now I'll see you in the next session. Till then, take care of yourself. Bye bye.